Hey guys, we're moving on today with 814, lateral surface area. So again, it's similar to yesterday, but we're learning a new vocab called the lateral surface area. So your objective, of course, is to apply formulas to find the lateral surface area of three-dimensional shapes. Now, yesterday I spoke to you about surface area being the amount of gift paper I'll need to wrap a present. Now, lateral surface area is the total area of the surface of a three-dimensional object, not including the bases. So since the lateral surface area does not include the bases, I actually added two pictures here so you can kind of see. If your gift shape is in the shape of a cylinder, when you're thinking of lateral surface area, you're thinking that I will not be wrapping the top and the bottom. I'm just going to do the outside. If your shape is in the form of a box, I'm not wrapping the top and the bottom. Okay, so let's take a look at some examples. Before we do that, I do want to recap and make sure you have these two definitions copied in your notebook. A lateral surface area for a prism is the total surface area of only the lateral sides of the prism. So that's not the bases, not the top and the bottom, whereas the surface area is everything. So here's an example. You have this box. So I'll be wrapping everything. So this side will be wrapped. This side will be wrapped. Of course, this would be a ×2 because we have one on this side, one on that. Then this will be a ×2, one in the front, one in the bottom. The top, however, here where I got some like kind of lines, those will not. So no wrapping. So when we do the lateral area, it's going to be 2 times 6 times 20 plus 2 times, if this is 6, here is also 6. So 6 times 4. And then plug everything into your calculator. This should work out to be 288 yard. And then it's area, so it's square. Right, again, you're wrapping this gift, but we're not wrapping the top piece and the bottom piece. Now, what if we have other shapes? We talked about cylinder. You're wrapping this gift for Christmas, and we want to wrap everything except the top and the bottom. Now, remember, when we talked about surface area yesterday, your formula was 2 pi r squared plus h times 2 pi r. Remember, this 2 pi r squared we said was the top and the bottom. We're not wrapped. This is a big no-no. And then the bottom is a big no-no. So the formula is actually removing that to get the lateral surface area of this guy. It's just h times 2 pi r. So the height of this is 13. The radius is 6. Excellent, because this 12 represents the diameter, and the radius is 12 divided by 2, which is 6. Now it says rounded to the nearest, what are we rounding? The hundredths. So that means when you enter everything in your calculator, we are going to go ahead and enter the pi into your calculator. And then let's see what we get. You should have gotten 490.08 rounded to the nearest tenth is 490.1 inches square. Right? I want you guys to think of this as literally, we talked about nets, we talked about different type of formula to find areas. It's not putting everything together. Now the last one is a little complicated, right? This one has some steps to it. So let's start it. It says find the lateral surface area rounded to the nearest square centimeters, which means, you know, just fancy way of saying whole number. Now, what shape is this? Perfect. Look at you guys knowing your three-dimensional shape. It's a triangular prism. So that means this is the base. The base is in the shape of the triangle. So when I find the surface area, it will be this side in the back. It will be the side in the top. And then this piece in the bottom. Okay? Not the two bases. So if this is 16, this is 16. So let's call this the back, right? So the back is 10 times 16 because it's a rectangular. We're going to call this piece the top, but we don't know this piece right here because so it's 16 times something. So the top is something times 16. We need to figure out what goes here. But when you look at this shape right here, it's a rectangular, it's a triangle, right? Same thing, let's look at the first one. You can actually see that better. It's a triangle. This is a 90-degree. The little box is right there. I probably messed it up before. So let me go back and go forward one more time so you can actually see that. And I'll rewrite it. It's okay. Right here. See that little box? Right? So we said this was the back. And then we had the top piece. The back was 10 times, and this is 16. And then the top, we needed to, oh, that's a plus. We need to figure out what it was. Something times 16. Now, because it's a right triangle, I can call this x and do Pythagorean theorem. So 10 square plus 15 square plus x square equals x squared. So 10 square plus 15 square is actually 325. And the square root of that is, I did all the work, but make sure you, in the calculator, it says actually 18.03. I just did 2 decimals. So this is 18.03. So now the top would be 18.03 times 16, and then we of course have the bottom piece here, which is this guy right in the bottom here, the one that I'm outlining, which is 15 times 16. Now I want you to, before you do any calculations, what I want you to do is just pause the video, internalize that for a little bit, let it sink in, see if you understood where I'm getting those numbers from, the Pythagorean theorem, make sure it works. Jot any questions that you may have so that you can shoot me a message on Google Classroom or email me, whichever works for you. Now, let's work this out now that you had a chance to think about that. So 10 times this is 160. If you plug the 18.03 times 16, you will get something like 288.48. Where's my decimal? And of course, 15 times 16 is 240. When we add all of those together, we get 688.48, but the question asks for whole number, so that will be 688 centimeters squared. And that is my final answer. Now, the last one was quite complicated, I'm not gonna lie, because we got some Pythagorean theorem happening here, we got a triangular prism. It's not just simple and straightforward. So take a minute before you start this worksheet. You know, guys, what to do. Make sure you show also all your work, have integrity. Remember, that's one of your school's motto, have integrity when you're completing this worksheet. I prefer you get something wrong versus in just copying. Alrighty, show me a question if you got any of those. Have a great day.